So, I'm going to try to solve this equation. So, when I see a rational expression, I factor it. So I'm going to factor this thing as much as I can. It looks like only this part might factor. So I'm going to rewrite the rest. Now, what multiplies to positive 3 but adds to negative 4, minus 3, and a minus 1. And I rewrite the rest of this equation out. And I think, how do I solve an equation that has rational expressions in it? Well, there's a trick to getting rid of fractions. And that trick is to multiply everything by the common denominator. So I'm just going to write the common denominator above each of these fractions. And the common denominator is x minus 1 and x minus 3. I want to make sure that every single term gets the x minus 1 and x minus 3. The common mistake is this last one. People will forget that even though it's a term, people will forget to multiply it by the common denominator. Now, why do we multiply everything by the common denominator? When I multiply this first term, this is on the top, and this is on the bottom, and they'll cancel. Do you see any other ones that might cancel? Well, the second term, I see this, and this one cancels. And the third term, this one cancels. And the last term, well, none of them cancel. Now, what I'm going to do is multiply whatever's left. So I'm going to multiply 2x by this piece here. So 2x times x minus 3 is 2x squared minus 6x. And this next piece, everything canceled except for the x, so I'm just going to have a negative x. On the other side, I'm going to have an x plus 1 times an x minus 1, which is x squared minus 1. And over here, I've got to multiply this negative 2 through to this. So what I'm probably going to do first is just FOIL this together. X squared minus 4x plus 3, which happens to be just this piece here. And then I'm going to multiply the negative 2 through to all of those pieces. So negative 2x squared plus 8x minus 6. Now, I have something like that. Looks kind of big and kind of scary. I'm going to collect my like terms on each side first and see what happens. So on the left-hand side, I have 2x squareds minus 7x. On this other side, I put my x squareds together, so I get negative x squared plus 8x minus 7. Now what do? I'm going to put everything to one side of my equation, so my x squareds are positive. So I'm going to add an x squared over here, gives me 3x squared. Minus 8x from both sides, minus 15x, and add 7 to both sides. Now I'm going to see if this thing can factor. So this is my decomposition type of factoring. What two numbers multiply to 21 but add to 15? There is 3 and 7, but they don't add to 15. 21 and 9, they don't add to 15 either. So looks like I'm going to have to use my quadratic formula. So if something doesn't factor in the first 30 seconds, I just go to my quadratic formula. X will equal the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. And where do these letters come from? A is the coefficient in front of the x squared term, b is the coefficient in front of the x term, and c is the constant term. So the opposite of b will be 15, plus or minus the square root of negative 15 squared times 4 times a times c, all over 2a. Now, I always look at the discriminant part first to see if I can solve it. Take out my calculator. I've got 15 squared minus 4 times 3 times 7 is 141. So I get 15 plus or minus the square root of 141 all over 6. So one answer would be 15 plus the root of 141 divided by 6. And the other one would be 15 minus the square root of 141 divided by 6. I hope you found that helpful.